Today I'm gonna show how to research models from Last of Us PS4 remaster. Must say that this example will show that nowadays formats are very simple. This is how it will look like. Many years before, graphics chips couldn't handle that many bones or that many faces like it is here. And developers must split everything into small parts like submeshes, even very small submeshes, make remappings, bone remappings. Everything was complex, and nowadays it's much simpler than that. I will show this in this example, how to get this kind of model from a file called infected female runner. Let's open it. There is a header, then some kind of table, a long table, some names, some numbers. It's all very different. And this is now looks like bone names, thumbs, index, fingers. Okay. More data, lots of different data, different kind of table, and so on. If we scroll down the whole file, now it looks like a geometry, floating point numbers, lots of them, all kind of stuff. This is a texture. Yeah, how can we even find anything here? There is something looking like shaders, wrinkle maps. Everything is here, not just like a model and skeleton. Everything is here. Let's go somewhere in the middle of the file. And there is something looking like face indices here. They go from 0 to 8 something, 800. Yeah, and before them there are some floating point numbers. This BE, 3F, every 4 bytes, this clearly show us this is floating points, probably geometry. If we scroll up, we can find the start of this geometry part. This will be somewhere here, because this is definitely not geometry. So let's try to read everything from here to there as XYZ coordinates, because it's clear that is not like it's usually done in games, like coordinates, tangents, normals, colors and weights, everything in one place. Here it looks like there are XYZ, XYZ, and let's try build a model from this data. Well, it looks like this. It's definitely not the right data, and because of shape of it must be normals or tangents, because they are all normalized. So let's see. This is not the geometry part. So let's scroll more up, and this is something else, some more geometry part. And there is a text. So it's possible that this is here the start of geometry data, coordinates, then probably something, and normals and tangents, and then face indices. So let's try this and build a model from it. Wow, now it looks much better. This is definitely head of that Vivian, but the faces are all incorrect. Why is that? So let's return to the file. The coordinates are correct now, probably, but not the faces. what can be wrong? They go from 0 without 2 bytes, like 4F5, 4F7, up to a number about 800 with something, and probably end here. This is where I take the end of them to build that model. I see 0, and there are just too many zeros here. It can't be like that. It must end somewhere in the middle. So we can see that this is not possibly a phase indices because they repeat too many times each. This 10, 10, 10. It's impossible to be a real phase indices. So they must probably... Oh, you see this 0, 1, 2, 3. So this is probably the beginning of phase indices data. And they will go to 0, 1, 2, 3. Like every 100 will take approximately the same size. And this above them, this is probably some different data. So let's try again to build a model from starting from here to there to 800. Okay, now it looks like a proper mesh. So we found one mesh in that file, and it starts from phase indices start from here. We can calculate their count. You can just measure a size from here to the end, divided by 2 bytes, and you'll get 30, 20 in hex phase indices here. And then if we go up to the place where we had coordinates, and here, if we calculate the size from here to the end of this block, like here, this will be 6930C. And divided by C, which is 12 bytes, like 3 floating point numbers, we'll get a number of vertices. Like this will be a number of vertices. So now we must try to find a link to this data. Let's say we go to where faces start and look for this offset, 100B44. We should enter this number backwards, 44, 0B10, because it's little endian number. There is no such number here. Then we know that faces, vertices will start from here. This is where we know this is a correct mesh starting from here. Let's try searching for this. And again, nothing. Then we can try searching for the count of, again, backspot, 8C5 vertices. And there it is, only one occurrence of this. And this is a count of phase indices. So this must be a description of a mesh. A different mesh, they are all near, probably 8 submeshes here by count of this FFF. We don't know exactly where they start. Maybe this is probably the first submesh or something. Well, actually, if we calculate the distance between two FFFs, this will give us the size of one submesh. It's 88 in hex. So we can now probably know the number of faces and vertices for each of them. What is this? 3. We don't know. Okay, now here near these numbers must be this must be offset to the face and vertex buffers, but they do not correspond. We have them somewhere at different places. How can this be? Well, in this case, probably the bone table will help us, because we had that bone list starting definitely from here, root bone, 8 bytes later, 10 bytes later. And this, just before that, I noticed that when I first opened the file, this is actually looking like the offsets to those names. But this F990 do not correspond to the offset of the first bone. Well, actually, that's quite possible. This is just a segment of a file which begins from somewhere in the middle, which contains all the geometry. So if we just subtract this offset, we take this offset and subtract that F990 from that, this must be the point where they count from to calculate the offsets, the beginning of a chunk or a sub-segment, a part of the file. So if we go to that offset, so this must be the beginning of a segment where they count from. Well, interesting that this 6F70, if we go to the beginning, we'll see this number here. So this is probably, and this one is really close to it. So we have probably here in header, we have a table of chunks. This is the beginning of the first one, and that's its size, because if we go here, we'll see some kind of magic word, and then this is the same number as here. So this is probably the size of it. If we add this to this, this will be next, the start of next one, and then it's size 6 with something. And in total, we'll have 4 of them. And this 4 is here. So after this, we can say that, and 2C is probably the offset of the first, offset of the chunks table, which will end here. So we can now save all the chunks and see what they contain. And that head mesh is right in the end of this first chunk, these phase indices we found. But the submesh's description is in the second chunk. That's the place where we found them. It looks like this number, F9BD4. F9BD4. Oh, that's actually the correct beginning of the phase indices part. And if we go here, the right offset for the vertices part is now D2C80. This will not be found here again. But it will be found in second chunk. What's this? This is a kind of table of offsets at 5BE something. And if we return to the submesh description, we have 5BF80, which will be exactly here. Oh no, it was 5BF80, not BE. BF like here. So this is, remember that number 693C? That's the total size of our vertices buffer. So this must be in a submesh description a link to vertices and faces, but problem is we have these submesh descriptions in one segment with the links to the first segment. Well, that's normal, but the problem is if we check other submeshes, they will be in different chunk. Well, it can be possible that the head is in the first chunk and everything else in the second, but check this and this is wrong. It could be that probably, I even checked that probably the head is in the first chunk and all the face buffers in the second chunk and all vertices tables in the first one, but no, it looks like they are all placed randomly. Like we have every link we have in this file can lead to any chunk of this file, and there is no system in this. It means there must be some way to tell for each link what it leads to. Well, how can we find this? In this Vivian mesh, we only have two chunks with submeshes, which will probably marked at 0, S0, S1, and 1, which is not very easy to detect. Maybe this one is a chunk number or something, but this is just too common. And I checked all the submeshes, this one and this one is not connected to a chunk number. So we probably better find another model which has more chunks with geometry, like this Tommy. It has 5 chunks. First 3 of them will have geometry. The fourth one is very short, and the last one contains something different. You know what? Do you remember what was in that first table? Zeros, like in this column, there are zeros and ones. Just a rare 3 or something, but most of them were zeros or ones. Yeah, and in this Tommy file, right from the beginning, we have 2, 1, and 3. So it really looks like this table, this first table, which is just a small chunk before the very first chunk, this can be related to the problem. So let's see. If we have our offsets here in this table, we have the offset to the face indices here. No, it's already in the end of the file. That's our submeshes table. So these are not the actual offsets in the file. Then what it is? So let's go back to our submesh description and see if the offset of the offset 5AAB8 is in this table. And it's here. So this and they're all near, really near. So it can be that this is the offset in the chunk, which must mean that the chunk number 1 points to a place in chunk number 1. And this is an offset, a link in chunk number 1 that points to a chunk number 0. And in this Tommy file, there will be more chunks, and this is a relocation table. We can check more offsets and it will be actually correct. So that's usually how relocation table, this is not very usual for a game, but this is how they did it. So game probably loads all the chunks in different parts of the memory, and then it needs to correct all the offsets to be a proper memory addresses. That's why they did it. So now, actually, we can read all the submeshes, find the offsets here, which point us to vertices and face buffers, and build a model, which will look like this. All the submeshes, we can select them, separate them by materials, 8 submeshes here, all the geometry and faces extracted correctly. We need to also handle the texture coordinates and bones. I will show this in the next part of this tutorial. Thank you for watching.